Hi guys, welcome back to GarageTech with me, Darren, and this is episode 3 in this series of how a coolant temperature sensor works. So thank you for joining. So in this episode we're going to look at how to diagnose and check your coolant temperature sensor and the system, and if you have got anything to check any fault codes, I'll talk you through what some of these fault codes are and where you need to go to start actually checking. So there's quite a lot of information up here on my board, so I'm just going to talk you through that first. So up here I've got some fault codes. These are some of the most common fault codes you're going to get for your engine coolant temperature sensor. So I'll run you through these. We've got some possible faults, and then over here we've got some possible kind of measurements. Now bear in mind, obviously, depending on the application that you've got, your measurements may be slightly different. I'll pop up some different charts so you can have a look at some of those. So these are some of the common sort of measurements that you're going to get. So I'm going to take you through this looking at the fault codes first and kind of guide you from there, and that way then that will take you through the process of actually what potential checks and stuff that you're going to have to do potentially with your coolant temperature sensor. So the first two I'm going to cover off is malfunction and intermittent. So these two, so that's the P0115, P0119. The chances are, if you've got either one of those two fault codes, you probably may have one of these three in the middle at the same time. These are typically, whereas it says malfunction and intermittent, so if you've got, well, the malfunction one pretty much is going to tell you it's detected a fault on the system, or it's gone outside the parameters which it's expecting, whether that's for a quick short period of time, hence the reason why you may get the intermittent one. But generally between those two, it's going to tell you that you've got a fault on the system, you need to go and check it. The chances are you're probably going to get one of those two and one of those three at the same time. So the other ones to look at is then this range performance, then which is 0116. Then you've got P0117, which is circuit low or closed. That's effectively saying that the ECU is reading a low voltage. And then if you've got P0118, that's circuit too high or open. That's basically saying that the engine ECU is reading a high voltage reading. So in terms of my possible faults, as with most of the systems, or particularly on the systems, the electronic systems on the engine, there's only really three things that are actually really going to be wrong. It's either going to be the sensor itself faulty, so the sensor inside could be just reading the wrong reading because it's gone out of its own calibration. It could be shorted inside to itself, or it could be an open circuit. So the sensor could be faulty. Typically 80% of the time it's probably going to be the sensor. Now when I say it's 80% here, this is my personal experience. It's not necessarily the facts. This is just what I've experienced over the years. The other one then is faulty engine ECU. You know, is the engine ECU actually faulty? Typically the engine ECUs are pretty reliable and they don't go faulty that often. And typically if it goes faulty, then you've definitely got some bigger problems than just an engine coolant temperature sensor fault. The other one then is the wiring and the circuit, or the plug connector, etc. That's typically the other thing that starts to go wrong, particularly on older cars. You know, obviously where the wiring's a lot older, depending on where the car's been stored, it's quite common for rats and stuff like that to get into the engine bays and start to chew through wiring harnesses. And actually there are some models of vehicles out there that do have known issues where the wiring is chafed through and it's broken, etc., which causes a fault with the actual wiring. So with any of this stuff, before you start going mad and doing loads of bits and pieces, I'd say check the plug. So obviously the plug will look something similar to that. It connects onto the coolant temperature sensor. Check inside the plug to make sure you can't see any kind of corrosion, or the pins are all intact inside there. Have a kind of visual inspection of the wiring as best that you kind of can. That's some of the initial checks you're going to want to do straight away before you start actually taking the sensor out and bits and pieces like that. As I said, if you've got a fault code reader, that's really going to help, particularly if your fault code reader, you can measure some of the measure values or the data blocks with it, because also that will also help aid you in your diagnosis. Now, if you haven't got some of those things, hopefully some of the tips and stuff I'll talk about will help you get through deciding whether it is an actual coolant temperature sensor fault or not. So as I've got on here at the bottom with the wiring, typically with the wiring circuit itself, you've only got really then 3 potential faults on there. It's either going to be an open circuit, which basically means there's a break in the wire, so the wire's broken. A short circuit, that means that potentially 2 wires are touching each other, or it's touching the frame or body of the vehicle, so you might hear the term short to earth. And then the other one is a resistive circuit, so there's some form of additional resistance in the circuit which is then causing the reading that the engine control units get in to be slightly incorrect. So again, sometimes a bit of a common fault. The temperature sensors will leak coolant that can go up into the actual plug, then it can get corroded inside, then obviously the electricity can't pass through the circuit correctly, and particularly with this type of circuit where it's based on resistance measurements, that's really going to affect what the reading that the engine ECU is taking. So that could be a possible cause there. So if we think about then our 3 main ones, as I said, so range performance. Now with the range performance, you may get some additional information with that. It might say range performance high, range performance low. Then as I said, we've got circuit 2 low and circuit 2 high. So if we start with the range performance, and if we just look at what we've got down here on this particular graph, typically when it's saying that the range of performance, it means that it's gone outside of the parameters which the system has been set up with. So typically all these sensors on the vehicle will start with 5 volts. A couple of reasons for that is, well, our battery is 12 volts. When we're cranking the engine over, the battery voltage will drop to about 9 volts. So if all of our sensors worked on 12 volts, when you're actually physically cranking the engine, well, the sensors are not going to have enough voltage to actually work and get the correct voltage readings that it needs. So all of the sensors typically work on a 5 volt range. That way then there's always going to be sufficient amount of battery power in the battery so that the engine and the rest of the consumers, etc., can function properly. So we start on 5 volts. So this is a link to this kind of a graph down here. So I've got 5 volts, and then typically you've got some sort of parameter range. So depending on the engine or ECU manufacturer, etc., it may be slightly different, but in this example, it will know that if the voltage is over 4.8 volts, then the circuit voltage has gone too high. So you may get this range performance too high, so it knows that it's gone too high. As well, you may get a fault where it comes up, the temperature has gone below minus 40 degrees. So it might be that you've got a range performance. It might just picked up that actually the outside temperature has gone below minus 40 degrees C. The other side to that range performance then is too high. And again, with that one, then we've got 0.2 volts down here. So if the voltage drops below 0.2 volts, again, it may put up that range performance. It also may put up the circuit too low because of the low voltage reading. And again, it may be because actually the engine has gone over 140 degrees C. So again, that range performance may be if it's detected that. So a couple of checks that you can do straight away, as I mentioned, check the connectors as best that you can, but we can do a resistance check on the actual coolant temperature sensor. Now, depending on where it's actually located on the engine, you can actually either do that in situ. So what I mean by that is whilst it's in place in the engine, whenever you do any resistance checks, first thing you need to do though is make sure that you take the plug off, because you can't do any resistance checks with the plug still on, because then you're going to be doing a resistance check of the whole circuit. You want to just do a resistance check on the component itself in isolation. So always make sure you disconnect it. Now, if you've got some sort of test wires or something, or just some wires that you can plug in to do the tests physically yourself, set your multimeter up to ohms, and then you'll need to cross-reference some sort of graph to find out actually what the resistance value should be at the particular temperature. So if your engine is cold, now I've just got on here 15 degrees, typically you should be seeing around about 3 kiloohms on your multimeter. And then if the engine was hot, you should be reading roughly around about 3.3 of a kiloohm. So if your engine is hot, so cross-reference that with some graphs and check. Now obviously it's easier to check whilst the engine is cold compared to then obviously when the engine is hot. So best, my advice would be to test it actually when it's cold, and then try and have another go when the engine is hot. But the main thing is that what you're trying to look for there is that the resistance value is obviously, as hotter the engine is getting, lower the resistance value is actually coming down. So that's the main thing there. Other thing to kind of check and look for as well, if you have got some sort of diagnostic tool where you're checking your fault codes, if you can check your measure value blocks, if you can unplug the sensor and then check what the temperature reading is whilst it's unplugged, it should be minus 40 degrees. Okay, so that will give you an indication that part of the wiring should be working correctly. So that's looking at that range performance. We think back to our circuit 2 low and circuit 2 high again, and we think about what checks we'd have to do on our wiring. So if we think that our sensor's okay, we need to think about our voltage readings then, and what voltages that we're going to get. So using your multimeter, and again you can cross-reference this as I just mentioned using the data blocks. Now the best thing to do is obviously in a case of a circuit too high or open, that kind of relates to like an open circuit type of fault. So effectively what we're saying there is this plug is effectively, it thinks that it's disconnected. The chances are that you've probably got an open circuit, and you could have an open circuit on the earth, or you could have an open circuit on that live wire. But effectively, let's just, for this example, we'll say the wiring has been cut open on that supply line down to the actual sensor. So ideally with your multimeter, then you put one probe on a good earth. So I've just demonstrated that as the engine somewhere. Ideally you want to go to the negative terminal of the battery. And then with your red probe, what you need to do then is go and test at the actual sensor. So we'll go to that pin there. So let's just say, for example, that's pin 1. That might be pin 2. And what you're looking for there, when the ignition is turned on at that particular point, depending on obviously the temperature of the engine, ideally you probably want it when it's cold. So you should be seeing 3.5 volts. Now, if you're not seeing 3.5 volts or any voltage at all, that's immediately going to give you an indication that there's a problem with that wire going back to the engine control unit. Now, if you're not sure about your wires and what's what I suggest you do is get yourself a wiring diagram like that, and that way then you can have a look at the wires and the pin numbers, so you can quite clearly see on here that says signal and that one's ground. So that gives you an indication straight away, and if I zoom out you can see that bit. See, that's the engine control module, and there's your actual sensor. So if you can get yourself a wiring diagram, it will make things a hell of a lot easier, because then actually you can see what pins and wires you need to go to straight away. So in that example then, as we said there, we've measured 0 volts. I put a 0 there on my multimeter. So ideally you want to trace that back now. So if you can, sometimes it's quite tricky, but you want to try and get all the way back to the engine ECU, and you want to measure there at that point. So in this example, the likelihood is that then you should be measuring then 5 volts at that engine ECU. So that's going to give you an indication that you know 5 volts is coming out of there, but it's not getting back to the sensor. So in that example, you'd have to probably chase the wire back, have a look to see if you can find where the cut in the wire is. The only other kind of test that you could do is put like an overlay wiring harness on it. So that would mean pinning a new piece of wire into the ECU there, and then putting it into the temperature sensor on that side. That way that would give you an indication that it's definitely that wire that's no good. You could also do a resistance check. So you could unplug the plug there, unplug the plug there, and do a resistance check on that wire, often known as, you might know, often known as more of a continuity check. But personally myself, I don't like to do the continuity checks, and you might have multimeters that beep and stuff like that for you, but actually I'd rather do a resistance check, because that way then if that piece of wire only had one strand left in it, and it was only then, you know, when you're wiggling the wire around, that's when it becomes open. Potentially with doing the continuity check, you may not find that. Okay, right. Let's just think now if we had an open circuit on the earth. Okay, so let's say, for example, now we've got an open circuit on that earth wire. If we go and do our first check over here, we're not going to pin 1 anymore now, we're going to go to pin 2. Okay, if you went to pin 1, you're going to see the 5 volts because it's coming all the way down to there. So in pin 1 you get 5 volts. In pin 2 you'll also get 5 volts. That's just going to indicate then if you're getting 5 volts on both of those pins at the temperature sensor. And don't forget, when I talk about measuring this voltage at the temperature sensor, sorry, I've got loads of bits and pieces on my bench here. Don't forget, you're checking this now with it still plugged in, and you're going to use some sort of back pin like this. And all you want to do is then, like it's got a rubber boot on it like that, just pull that rubber boot kind of off. You'll be quite gentle with these because you don't want to damage the wiring. Then ideally what you want to do then is within the back there, you'll use a back pin like this and just back probe it in. So you're kind of doing that in the back of the actual plug. Okay, and then you use your multimeter in that bit. And then obviously if you can just about, I don't know whether it'll go into focus, but it does say on there there's a pin 1 and pin 2. So if you consult your wiring diagram, you'll know which pin you're actually in. So that's a good way to do it. So as I mentioned, you go to pin 1, you're probably going to get 5 volts. Go to pin 2, you're going to get 5 volts. That's going to give you an indication then that you've got an open circuit on that wire that's going back to the engine ECU. So if you go back to the engine ECU, we check there, for example, with your multimeter set up as it is, you should then read 0 volts. And that's just going to confirm that you've got an open circuit then on the earth. So that kind of covers off the potential of that 0118 circuit too high or open fault. Now if we think about the circuit too low and closed, typically with that one you're going to have a short. So again, you want to check the actual sensor itself to make sure that obviously the sensor inside there's not shorted to itself inside. But the chances are there that you've probably got a chafe in the wire or something's happened in the wiring. I'll just use a demonstration of like a screw. It's gone through, in this example, I've just gone through both the wires. So somewhere in that piece of wiring harness, I imagine that's the 2 wires. I've just opened them up now, but somewhere in there potentially it's chafed through and the 2 wires are potentially touching each other. Okay, that's going to give you what's known as a short to earth, because that voltage that's coming straight out the ECU is going to go straight through that short and back to the ECU again. You know, the electricity is going to take the easiest route, and it's going to be easier for it to go down there, through there and back than it is down there through that other resistor and back up again. So with that in mind, if you take your multimeter and use to just go and do an initial check on the wire up here, you're going to get 0 volts. Okay, and the same if you was to measure here, going to be 0 volts if you was measuring with your multimeter, because basically all of the voltage is being consumed by that resistor that's inside the actual engine control module. So inside here in your ECU is going to be measuring 0. That relates to that circuit too low, because it's saying that I can read a low voltage reading. Okay, so the chances are for you is then to look at the measure value blocks. I keep calling measure values or data value blocks. You're probably going to get minus 40 degrees. Okay, quite hard to check that on your gauge, because obviously your gauge probably just goes to like a 0 or whatever, and it can't really go any lower. So checking that short to earth, how are we going to actually identify that we've got a short to earth in the first place. So if you've done your measurements there, you've got 0, you're going to check there, you probably got 0. That's going to give you that indication. If you've checked your sensor and you think that's okay, you suspect it might be a short swerve on the wiring, what you need to do is, in any short circuit fault finding that you conduct, you need to disconnect the plugs from the circuit and make sure that the system is turned off. So with that wiring all disconnected, what you can then do is check for resistance between the two wires. That will then immediately give you an indication that they're shorted to each other, okay, in that scenario. So you can check for short to each other, obviously using a resistance check. Or if that's okay, and it's potentially then it's shorted to the body of the vehicle, then what you could do, and this is a different way of setting up your multimeter, and everyone does it slightly different, but this is the way that I do it. I like to do it this way. I put my red probe on a positive 12 volts, so ideally on the positive terminal of the battery, just depends how long your leads and stuff are. And then I go testing with the black probe this time. And what I'll then tend to do is then you can go to both of the wires, but you might go to that wire there. And then if I've got then 12 volts on my multimeter, I know that that piece of wire, that should be just a piece of wire floating in the air, as it were, I know that that wire somewhere is touching the body of the car, or it could be that it's chafed out onto another wire that goes back to maybe the engine ECU or whatever it is, somewhere else, or another earth. So they're just some of the checks that you need to do. That will give you an indication that you've got a short swerve. You do exactly the same on the other wire. And again, if all fails, what you can then do is do an overlay and then run a new piece of wire basically between there and there. And then that will give you a confirmation that actually, yes, you definitely know there's a fault with the piece of wiring, the original piece of wiring that's there in the car. Okay, so that kind of covers off those. Again, resistive circuit. If you think you've got a resistive circuit fault, again, you need to rely on your voltage measurements. Now, if your engine temperature is low and the voltage that you're getting down here is still really low, so perhaps you're getting, you know, your 2.5 or less than a volt, that's going to give you an indication that actually you've got more resistance in the circuit somewhere, because that's actually consuming part of that. So your engine ECU is reading a lower voltage. So again, similar sort of checks I would do, similar to this, do the resistance check on those pieces of wire to check see if there's any resistance between them. Okay, I think that's pretty much covered off most of the checks and bits and pieces that you can do. Hopefully this video is giving you some confidence and some knowledge in how the actual engine coolant temperature sensor works. What you can do is take some of this knowledge from this video and you can replicate and use that for other systems. As I've mentioned before, the engine coolant temperature sensor and the way that it works, you know, in this respect is the voltage divider circuit, is commonly used for most of the other temperature sensors on the vehicle. So as I said before, whether that's another, because you might have multiple coolant temperature sensors or engine temperature sensors, you know, ambient air temperatures, oil temperature, etc. So the same philosophy and diagnostic techniques will be exactly the same. So hopefully you like the video, guys. If you have, give it a thumbs up. Put some comments below. If you've got any issues and need some help diagnosing your potential issue with your car, drop me some comments. I'll see what I can do. I can't fix everything remotely, but let's give it a go, and I'll catch you on the next one. Take care.